Good afternoon, everyone. Welcome to this week's episode of the M Word. My name's Robin. I'm the technical director here at Man Machine in the UK. And as always, thank you very much for taking some time out of your schedules to join us for this session this afternoon. These sessions, for those of you that haven't seen them before, they air every Thursday, 2 p.m. And we really like to share a tip, a trick, a what's new, or a workflow just inside of one of the Autodesk tools that we sell and support as an Autodesk Platinum Solution Partner here in the UK. Last week we were looking at the construction industry and specifically rendering in Enscape inside of Revit. And today we're going to be looking at manufacturing, namely Autodesk Inventor, but something a little bit different. It's called iLogic. It is an automation environment that sits inside of Autodesk Inventor. And simply put, it allows you to use Visual Basic code inside of Inventor, quite simply, in fact, to automate mundane tasks, automate parameter changes, or even completely drive your model from scratch. We've got a load of videos on this and on iLogic and automation in general on our YouTube channel, so please go and check them out. Don't forget to give us a like and a subscribe whilst you're there. But today, what I really wanted to do over the next sort of 25 minutes, half an hour, is really try and simplify it and explain how we use iLogic to start coding inside of Inventor. How do we know what to type? Some basic coding options. So how do we use an if statement? How do we use a for loop? And how do we start understanding what parts of the API that we should be or could be tapping into? So we're going to start from scratch. Imagine that you don't know anything about either coding or iLogic, and we'll just see how we get on, but really a focus on how to get started in programming Inventor using iLogic. So without further ado, I've got my tea. I hope you've got yours as well. Let's share my screen. And try again, share my screen and shrink myself down. There we go. And I'm in Inventor 25. iLogic has been an Inventor for many, many years now, and generally the functionality is the same whether you're using an older version. Generally speaking, code is backwards and forwards compatible, although there are some API changes every now and again. I'm just going to nip off camera. I can hear myself through the headphones. I'm on my own in the room today, and I can hear myself on the feedback headphones, and it's really off-putting. So just give me a second. I'm just going to run off camera and turn the volume down ever so slightly so I can't hear myself. There we go. Sorry about that. And then we will kick off. So I've actually gone into Inventor and I've downloaded a sample file. So if you want to follow along, go to File, go to Open, and then all the way down the bottom, you've got sample files, Open Samples. That will open a browser. And I've downloaded the Jet Engine model. I really like the Jet Engine because it's a fairly decent sized model. It's got a lot going on. And there's a lot of different files in there that you can use. But go ahead and pick one of these. Specifically for iLogic, the Rubik Cube is great. That allows you to really see some cool animations and automation inside of iLogic. But for today, download the Jet Engine model zip file. Once you've downloaded it, extract it, and then you'll be able to go ahead and set your project file. And all we're going to do is we're going to choose Open, and we're going to go and find the top assembly. So easiest thing to do is just organize it by size, and it's called _Jet Engine model. And we're just going to go ahead and open it up. And the first thing I really want to go through is really just getting started. Some best practices, what can I do, how do I do it, and how do I start driving some functionality with iLogic. And the first thing I want to show you is in the very top right of your screen where the question mark is, there's a tiny little drop down arrow next to the question mark. If you hit that, come down to Help, and then the second option on the list here is Programming/API Help, an API Application Programmable Interface. So we've got the ability to read through here, and it gives us actually some pretty good documentation about all the different aspects of the Inventor API. And what you need in order to push or pull specific information from it. For example, I want to go ahead and search for maybe an assembly. If I go ahead and search for assembly, you'll see based on that search under the index here, we get a load of different options. And it gives me code references for adding an occurrence into an assembly, or even an assembly component definition object. It's basically telling us specific parts of the API that we want to use. So I'm going to be a little bit lazy and go ahead and search for a document. And go ahead and find the document object. When I double click on these, it's just opening this little dialog box here, and it's allowing me to go and choose what I'm looking at. But I want to show you how to identify what it is that we need to do. And the first example that we're going to go through is calling on some information that sits inside this file and then using it to our advantage. And to do that, we need to think about what we're looking at within inside of the Inventor interface. So we have Inventor, which is the application. And then the application has open documents. Those documents are document objects. And a document object contains a number of different things. A document can be activated, it can be closed. It can be rebuilt, which is the same as manage and rebuild all. It can be saved. A document also, as well as having methods or actions, you've also got properties. And as well as the properties, you've also got other things that they contain. So if I go and look under a document, we can see that a document itself has something called a... Where have you gone? Where is it now? Document type. And a document type will allow us to identify whether it is an assembly or whether it is a subassembly. And all of these things can be driven and used by code to start the process of automating something. In other words, if I wanted to go through this entire file, loop through all the different occurrences that are in this file, and identify anything that is a part, or anything that is a sheet metal part, I can use some of these properties and some of these references within the code to be able to go ahead and tell me that. So that's exactly what we're going to do. It's not easy, this kind of stuff. You've really got to... I'm going to try and clear my glasses here. You've really got to have an appreciation of what it is that you're doing. So to come into this fresh when you don't know code at all is not particularly easy. But it's a really nice entry point for anyone that is wanting to learn because it's quite visual. So with this component here, the first thing I'm going to do is come to the left-hand side where my model browser is. And then at the top, I've got these tabs, Model and iLogic. If you don't have iLogic, click the little plus and you'll be able to turn on iLogic from the little plus. I also want to hit the plus and open up the iLogic log, which gives us the ability to view the log file that's being populated at runtime of any of my iLogic rules. Really good practice to get used to using that, and I'll show you how it works in a second. Once within iLogic, we've got rules that exist within the document, forms that exist within the document, forms that exist external and can be accessed by several documents, and rules that exist externally and can be accessed by several documents. For the purpose of today, we're going to focus on internal rules only. So I'm going to go to my Rules tab, and I'm going to right-click and say to add a rule. Inventor's going to prompt me for a name. So I'm just going to say my first iLogic rule and press OK. And then this will open up in turn a text editing window, which in my case, once again, has gone off the screen, and it looks a little bit like this. So you can pull this onto a second monitor if you want to. What's really frustrating is you can't access the Inventor interface whilst this dialog is open. So whilst you can have it on a second screen, it's kind of semi-pointless, but nonetheless, you can put it on a second screen should you want to. And then in this dialog box, if I just resize it to suit this window, we have code snippets on the left, which gives me a default selection of snippets of code which do exactly what they say on the tin. So if I wanted to update my Inventor model, I can go and find a snippet to update my model. If I wanted to pull an iProperty, I could go and pull a snippet that will allow me to access my iProperties. In the middle here, we've got our model tree. This is context sensitive, so I can go and right click on any of the options within my model tree, any of the components within my model tree, and start accessing parameters, start capturing the state of a component, so on and so forth. I've also got file trees, I've got options, I've got search and replace, and I've also got wizards such as to create a custom dialog box or message box, for example. Skimming over that really quickly, we're going to start over here, and the first thing I'm going to type in is option explicit on. What option explicit will do is it will tell iLogic that we're going to be typing in code, and it's going to force iLogic to make us type in code of a decent quality. To give you an example, if I turn option explicit off and I try and create a string, I could say my string equals it is Thursday. I can save that rule and it's quite happy. If I turn on option explicit on and start saving, it's going to error. And it's going to error and basically say you've not declared what my string is, because it's a string, it's a piece of text. Option explicit forces you to make declarations for things and generally pushes good practice and good coding. So I would always recommend that you turn it on. With option explicit on, we can then start writing. And the first thing we want to do in this kind of example is we'd want to declare. So rather than just saying my string equals, we would say dim to do a declaration. We would give our object a name, and then we would say what it is. So dim my string as a string, and then we set its value. That could be done on one line, or that can be done over several lines. So it makes you type in a little bit more, but it gives you better code. So we want to turn option explicit on. The next thing we want to do to be able to cycle through every component within our model is basically define our document, tell Inventor what is my document, and then go through and start building up some variables and some objects that we can reference. So to begin with, we might want to start capturing everything inside our log. When we run an iLogic rule, we can choose at what log level that rule runs at. Is it tracing, is it debugging, or is it info? I'm going to leave it on info. And the first thing I'm going to do is type in logger.info, open brackets, open speech marks, rule starting. So I'm going to put something within my log that says my rule is starting. Now I'm going to start declaring some things. So let's say that I want to declare OASI doc as assembly document equals this doc.document. Just that on its own, if you're brand new to coding, you're probably looking at that thinking, what the is that? And quite simply, I'm saying I want to have a piece of text that I can type. That piece of text is going to be OASI doc. I want you to know that that declaration is an assembly document. This is something from the API. You'll be able to pick this up from the code reference that I showed you earlier. And then I'm setting that to this doc.document. I'm then going to log it. I'm going to say logger.info. I'm going to open brackets, open speech marks, and I'm going to say OASI doc is, can't type today, is set to :space, close speech marks, and then I want to add a variable. So I'm going to do a space, ampersand, space, OASI doc, full stop, and then I get a load of autofill. It's telling me that my assembly document, because I've declared it And because I've got option explicit turned on, it's prompting me for things that exist, properties or methods that exist under an OASI doc. And with a bit of luck, I can come in here and I can say OASI doc dot full document name. If I say save and then click save and run, you can see that in my log, I have rule starting, and then OASI doc is set to my component. Maybe I want to get rid of the file path as part of that. So let's just go and edit the rule once more. And rather than using full document name, I can just use full file name. And if you use full file name, oh, it does the same thing. Okay, I thought one was different to the other, but apparently not. We'll just stick with full document name. That's fine for the purpose of this. I thought there was a difference between the two, but clearly I'm going mad. So there we have our first declaration. We've declared the assembly document. From there, I want to tap into that assembly document because we're going to want to use its occurrences. Now, when you're using this kind of coding, most things are named logically, not all of them, but most things. So in an assembly, we have occurrences. We know that because we know Inventor, and that's the terminology. So I need to identify where those occurrences exist. So from my help drop-down, I can go to help, programming and API help, and I can go and do a search for occurrence. From here, I want to go down and I want to find the occurrences or occurrence object. Let's just say occurrence. And then we can scroll this list and we can go and find the individual occurrence, or even occurrences is fine. There we go, component occurrences. So this will tell you that a component occurrence sits underneath the I forget the terminology now. Under the document, you've got component definition, and within the component definition sits your occurrences. So a lot of this is trying to find where the objects sit within the reference. Again, download the SDK, download the code reference, and identify where the things are that you want to pinpoint. But from here, we can do another declaration. So we're going to dim. We're going to say OASI def, and we're going to say as component definition equals our assembly, OASI doc dot component definition. So we define, again, a piece of text that we're going to use, what it needs to treat that piece of text as, and what it's set to. We can then say that our dim occurrences as component occurrences, plural, and then set equals OASI def dot occurrences. All this is doing, these declarations, is it's saving me doing things like this. This document component component definition dot occurrences. That's still a fine way to code, but you'll end up with lines that are long. So by making the declarations, A, it's going to give you that prompt, that autofill, and B, it just makes the code much nicer. So let's get rid of that line. We don't need that. We've defined our ASCII doc, our definitions, and our occurrences. Now, in order to loop through all of the occurrences within our model, we need to be able to specify that each one of those occurrences is an occurrence. So we also need to declare dim occurrence as component occurrence single. Make sure I don't have any spelling mistakes in here. But I'm not going to set this one. I just need it to be there. And then from this point, I'm ready to start doing something with my code. And the first thing I want to do is I want to say for each. So I want to do a loop. I want to say for each component occurrence within component occurrences, so for each single within plural, go and do something. So I can say for each O occurrence in O occurrences, do something. And then you write the word next. This will literally go through whatever code is in the middle here. It will run over and over and over and over again for each occurrence within your model. For example, I can say logger.info and I can say occurrence name and occurrence.name. If I save that and run that, within a second or so, dependent on the size of your file, we can go through and we can see all of the occurrences that exist within that top level. So it's going through and showing us this one, this one, this one, and any individual component that sits inside of those patterns. So it's looping through all of the individual components at this top level. If I wanted it to go through every single level, rather than for each O occurrence in O occurrences, I can say that we want to say, for example, let's say OASI def dot all dot OASI dot referenced. Is it all leaf occurrences? Hang on, it's been a while since I've done this particular one. Let's go back to O occurrences. Somewhere there is an all leaf occurrences. Occurrences. Oh, undo. There we go. So oascdef.occurrences.all leaf occurrences. If I save and run that one, this will then allow me to start going through every individual occurrences. Make sure I don't have any typos. This will then go through every individual sub-level component. And again, you've, as well as all leaf occurrences, you've also got all referenced occurrences, and you can go through and start running through different levels. Okay. Again, only a quick example today, so we're not going to go through every single thing. We're just going to go through all occurrences, but you get the general idea. You've got lots of different levels that you can go into. And then from here, what we're going to do is we want to identify whether that occurrence is an individual part. So as well as picking up the name of the occurrence here, I can also start picking other bits off the occurrence. You remember earlier I said about document type. If we can identify a property called document type, we can also pick up whether that document type is a part, sheet metal part, an assembly. So if I can say at this point that I want to define OOCDoc, that's a mouthful, OOCDoc equals a document, sorry, not equals, as a document. So define OOCDoc as a document, and I'm going to set it to OOccurrence.definition.document. And then because I have the document, I can say dim OOC type as string equals, I'm pretty sure it's just a piece of text. We're going to say that equals OOCDoc.document type. You've got type and you've got subtype. One of them is a number and one of them is a string. Let's just grab our logger just here and put that underneath, and we're going to say occurrence name and space is a and OOC type. If I save and run, we are occurrences. I've made a mistake somewhere. Occurrences on type occurrence. My mistake. If I run that now, it's going to start giving me this number. That number, again, if you look in the API, it will tell you that that is an assembly document, is 12291, and 12290 is a part. If I use, rather than document type, if I use document subtype, I think it is. No, document subtype. There's a way of getting the actual document type. There's a way of getting the actual text here. But again, for the purpose of today, unnecessary. But if I open up Autodesk Inventor API document, just opening up a browser and open up the API help online. So you've got this document type. This document type is what we're looking at, and then this gives us all of the numbers. So if we're wanting to individually identify the parts, it's 12290. If we wanted to say, show me a drawing, it's 12292. There's a separate subtype if it's sheet metal. For the purpose of this, I'm going to say, if OOC type equals this one, then do something. It is a part. And then I can say, rather than that, I can say that part is a part. And if hit save, run our rule, and now I'm only getting a list of the individual parts. From there, I can then start driving even more. So maybe as part of this process, and again, I'm conscious on time and taking overly long, but maybe as part of this process, what I want to do is I want to have functions within my code. So here, I'm going to have a rule which is called sub main rule. Then I'm going to have end sub. Maybe I'll just put sub main rather than sub main rule. So I've got a main piece of code that is running. And then down here, I'm going to have a function. So let's say function part code end sub. In here, I'm going to have part name as string. So this piece of code is going to run when asked, but you're going to need to send it the name. So after I identify my part, I can say that I want to run part code, and then the name I'm going to send it is occurrence.name. This will allow me to then run this particular sub of code or function, if you want to call it a function. And within that function, I can say logger.info, I am in the function. And then that function is going to say, once again, let's define our code and occurrences down here. We have to define them again because this is a completely separate piece of code. So we have our component occurrence. We're then going to say that we want to have our dim ooc doc as document equals this doc dot, sorry, not this doc, OASI, sorry, O occurrences dot item by name, and then we can say part name And then down here, I can say logger.info. I have successfully passed full document name to my function. If I save that and run it, get an error typically. Line 36, let's just have a little look. It doesn't like this one. Item by name, part name doesn't like. Okay, so in that case, what we're going to do is actually just send the occurrence. And then we're going to definition dot document dot full document. Really struggling to type today. Full document name, hit save and run. And then it's picking up information from the assembly in the sub. It's then running the function and it's passing the physical object that it's found into that function. So quite a lot to take in half an hour, but what have we learned? We have learned that option explicit on is our friend, and that allows us to make sure that we're writing code correctly, declaring variables and working as we would want to. We have learned that we can split our code up into subs or functions. We can have some main rule that goes and does something, and then we can have some subcode that goes and does something else. That's particularly useful if you want to run the same piece of code over and over and over and over again without having to run through massive for each loops or massive if statements. We've learned how to declare objects. We've learned how to write a simple for each loop to loop through things within an Inventor interface. We've learned how to do an if statement. If something happens, then do something else. And then we've learned how to trigger our functions based on something happening and send information to and from those functions. If you wanted to return something, just to finish this off, although this is a little bit useless as a function because it's completely pointless, to give you an appreciation, we can say that dim return string as string equals our document name. Let's comment out that piece of code with a quotation mark so that it ignores it. We can then say return our return string. If you write return, make sure you're using a function and not a sub if you're returning. When we use return, we can, in brackets, send something back. So I could say that this is dim part name, part full, let's just say full, part name as string. And then we can say that our full part name equals the result of that function. And then up here, we can put in a message box with our full part name in. Hit save, hit run, and then the output is the output of our function. So again, appreciate that we've gone through quite a lot in a very short space of time. But really the idea of today was to get you started in understanding quite what you can do and how to do it inside of Inventor. So in 40 or so lines of code, we understand how to create a sub, how to create a function, how to call that function, sending information in, how to run that function, returning information out, how to use the logger, and generally how to do some general bits and pieces like ifs and for each. If that's been useful, then reach out. We run regular iLogic training courses, which can be standard off the shelf or tailored to suit your individual requirements. We can also run fully consultation-based sessions on automation, should you have a task that you want to automate, even building fully fledged configurators, which you fill out a form and your model builds up for you. Just get in touch. If you found this interesting, let us know what you want to see next time. Get in touch and we'll be more than happy to oblige. I hope that's been useful. Until next time, take care and we'll see you next week. Bye-bye.